Welcome back to the channel, guys. So I think in last video we covered the introduction part to the entire comprehensive course in MySQL. So in this video we will be seeing about the introduction to database and MySQL. So before going to the term databases, so what comes to your mind when I speak about data? So data can be raw facts, figures, or informations, right? So this everything logical entities which when we combine becomes the data. So basically these databases are the place where this actual data is stored, right? So you can imagine this as like how we'll be storing our money in the locker or in the bank. Like there's a storage medium for everything. Water will be storing in the tub, right? Food will be storing in the fridge, etc. Like that. There's a place where we store the data. So why we store the data? Basically to access it and manage it, right? So in order to effectively manage and access the data, we obviously use the databases. So before going into the theoretical or the definition provided by the textbook, so let's understand like what the agenda for this video will be. So in this video we will be seeing about what is databases and the type of databases which are broadly classified into relational and non-relational or NoSQL databases, and also we'll be seeing the introduction to MySQL in this video, and obviously we'll be setting up MySQL also. So there are two ways through which you can directly use MySQL. The one way is using the CLI, which is known as command line interface or command line client, and the other one is using the UI. So it's named as workbench here, MySQL workbench. We will be using particular UI, so you can prefer whichever medium you want and communicate with the MySQL server here. Okay. So and also we will be seeing some basic MySQL comments here. So I think we will be seeing a lot more comments in coming videos. Okay. So let's get jump into the databases here. So what is database? So according to the definition which goes here like this, a database is an organized collection of data that can be easily accessed, managed and updated. As I told, a database is a place where we store the data, and it's an organized collection of data, meaning that the data which we store will not be in a random order, it will be in an organized way, right? It will be in an organized way so that we can easily retrieve the data and can be managed the data and can also be updated, right? The data can be accessed, managed and updated. So that's the reason why we are using the databases here, right? Okay. And coming to the databases are used to store, retrieve and information effectively. That's what I told, right? To store and retrieve the data or the information effectively. So the main purpose of databases is to ensure the data is stored in a structured and organized way, making it easier to retrieve and update. As I told, like the same definition in repeating here, the same thing, we are storing it to retrieve and updated data as per the requirements, right? So and coming to the example of databases in real world application, it can be in banking systems or it can be e-commerce website, it can be social media platforms and healthcare systems. Everything, like whatever in a digitized way nowadays uses a databases, right? So in the banking system there can be certain customer details or the transaction made by the customers or the account information of a particular customer. All these details can be stored in a database, right? And coming to the e-commerce application, it can be a product details or the user information such as login credential or other details, right? And the order details, inventory details, like what are the inventory like products present in the inventories, like that. And when it comes to social media, it can be different types of information or which can be stored in the database, such as user profile details, right? Like the user posts, user comments, right? And connections, like connections, it can be user having how many connections user may be having, right? The details can be stored. And in healthcare system, obviously patient records we can store, and appointment schedule between that doctor and the patient, and the medical history of particular patients, etc. can be easily stored in the database, right? And this is an visual representation of database. So let's assume there's an e-commerce application here, so there will be obviously a customer and there will be an order. So this particular diagram which you are showing shows us the interconnection of databases here, so that once a particular application is deployed in the actual environment for the user, they will be not seeing this type of visual representation. But as a developer or MySQL developer, you should be having an abstract idea how the data is stored, right? So it's just a visualization, like we will be not able to see like this, but this this is just a visual representation of how the data will be stored. For example, let's consider an e-commerce application. They are obviously customers. We will place the orders, right? So there should be an intercommunication between databases here. So let's consider like customer is a different database and order is a different database here. So customer and order database needs to intercommunicate between both so that they can come into an agreement here. What's an agreement here? Let's say a customer named A places an order for the customer, like for a product. In the product table, it can be any product, right? They will place an order. So order table needs to be updated once a customer place the product, because in order it will be like customer, now the current order of the customer is 0. Once he order for a particular product, the order count should be increased to 1, right? So I think no need to like cook your head with this concept now. So we will be covering this is a visual representation, so you can just keep in mind that the databases need to intercommunicate between each other for effective, or a full stack application is only possible when different database communicate with each other, right? That's only when all the capabilities can be built into an application, right? So here we can see the customer database is representing like, or is accessing the customer table here. Similarly, order is accessing the product table here, right? That's the detail. I think nothing to complicate more here. Just to keep an idea that the databases have interconnection between them. So coming to the type of databases here, so it can be broadly classified into two types. The one is relational database and the other one is non-relational or NoSQL databases. So what are relational databases? So relational databases are databases which stores in tables with rows and columns. So relation meaning it's a table, right? Relation is equal to table. So there is this particular relation in some language is referred to as particular table in English language. So this relation is referred to as table in English language. So coming to here, it stores data in tables with rows and columns, maintaining relationship between data points, right? So when it comes to relation table, you can blindly keep in mind that okay, tables are involved in this, okay, like that. So it's broadly classified such as tables and non-tables, like that, okay. So example can be MySQL, which is an open source, right? Which is an open source database management system, and PostgreSQL is an advanced open source RDBMS known for its extensive and standard capabilities, right? So I think we will be not going to PostgreSQL in our thing, so we will concentrate on MySQL. And coming to MySQL, like NoSQL databases, after MySQL databases, so what are NoSQL databases? So NoSQL stands for not only SQL, okay. So flexibility is the main key here when it comes to NoSQL. So design for unstructured or semi-structured data often require flexibility, right? So for that, often we will be using NoSQL databases. So what are the types of NoSQL databases? There is a document store database, key value pair store database, column stores database, right? And graph databases. So these are the types of non-relational databases or NoSQL databases, and they are particular example of the implemented databases. For documents such as MongoDB, and for key value we have Redis, and for column store we have Cassandra, right? And for GraphDB we have Neo4. And example are MongoDB and Cassandra are obviously famous. So MongoDB are used for document based NoSQL database, and Cassandra is a distributed column store, okay. Just to keep in mind, because we will be not going into NoSQL database, just to have a brief idea that there are two types of databases here. And this table clearly help us to differentiate between the keywords here, like key aspects such as data model, like how it's different from SQL to NoSQL, right? So this column, second column here represents the relational database, and third column represents the non-relational or NoSQL database, and the first column represents the key features which are like essential for both and how they differ, right? So if you go and check here, for the first feature, data model, in relational databases the data model are present in the form of rows and columns. So usually the data models are represented with the rows and models, like in the sense data is represented in the form of rows and columns, right, in relational database. So in non-relational database it's flexible. So how in the sense it's flexible, you can represent it as is key value pairs or documents or columns or graphs, anything like whatever suits your requirement, you can obviously represent you or choose a particular data model. And coming to the query languages which are present for relational databases are SQL. And similar for NoSQL, there are various query languages such as MongoDB query syntax. So this is a particular language, right? There are different languages which are used for NoSQL databases. And coming to the schema, it's a particular fixed schema. Like before building an application, we will take a pen and paper and write down the schema, or using any software, we will plan the schema first. So after that only we will jump to the implementation. So predefined structure. Obviously, relational database have a predefined structure. And coming to the NoSQL, like what you will say non-relational SQL, it's not the case. It's schema-less or flexible schema. So let's say I know a requirement about some things, and the other things I may not be knowing of a particular application. So what I will do is that I will go and write the code for whatever requirement I have. So once the new requirement comes to me, I will obviously make the schema more changeable, meaning that more flexible. Like I can change the schema at any time. That's the particular or more advantages of NoSQL databases here. So coming to the scalability, it is vertically scalable, meaning that we can increase the server capacity, right? And coming to the horizontal scalability, here adding more servers and nodes. So this is a particular theoretical concept. So just not to worry about this, just keep in mind that increasing server capacity is known as vertical scaling, and adding more servers or nodes is known as horizontal scaling. So moreover, NoSQL DB, they are like different architectural patterns here. So I think it's not required in our full stack thing, so I will not be discussing that. And coming to the use cases where relational databases will be used, they are in transaction system, obviously I told bank system, obviously simple relational databases is enough, I guess. And for business application which involve tables, obviously there we can use relational databases. And coming to the NoSQL database, real-time data, big data, or flexible data applications. So these are the types of use cases for NoSQL databases. And these are the examples of relational databases: MySQL, Postgres, and Oracle. And these are the example of node relation, which are MongoDB, Cassandra, Redis, and Neo4j. Okay, guys. So I think database concept is clear now. So let's jump into the MySQL thing. So what is MySQL? So SQL stands for Structured Query Language, and MySQL are the open source relational database management system, right? That uses usually SQL to manage and store data. Okay, that's the MySQL. So it's an open source relational database management system. Okay, and coming to the popular use, so since it's already in popular use, so widely used in web application, e-commerce site, and other systems that require fast, reliable, and data storages, right? Which require fast, reliable data store. Obviously, they can use the MySQL thing. And coming to the key features, they are ACID properties. So in this video, I will be telling about ACID properties. So what is ACID properties? ACID stands for atomicity, consistency, isolation, and durability. Okay, so what is this atomicity, consistency, isolation, and durability? I think it's not particularly required in full stack application, but as and when required, obviously I will be explaining in future video. But keeping this in mind, ACID stands for atomicity, consistency, isolation, and durability. What is this and how we will be using this? We will be explaining in coming videos, right? And class platform support. So MySQL runs on multiple platforms like Windows, Linux, and Mac OS. Obviously, it's like it's in class platform support, right? So obviously you guys can use in different platforms. And coming to the scalability, can handle large volumes of data, supporting both vertical and horizontal scaling. So obviously MySQL can be used for large amount of data also. And coming to the security aspect, it has a strong authentication, access control, and encryption mechanism, right? You can Google these keywords and get the definition of particular keywords here. And replication supports master slave replication and multi-source replication for fault tolerance and scalability. And coming again here, I think this particular keywords or theory is not required in our full stack development aspect. Just to keep in mind what is SQL capable of, I think these keywords can just be kept in mind, right? And storage engine offers different storage engines like InnomoDB, right? InnomoDB, MyISAM, and other, each optimized for different use cases, right? Yeah. So MySQL architecture and components. So this is a MySQL architecture, guys. So they will be in client layer, SQL layer, storage engine layer, and obviously MySQL daemon, right? So what is like you can see client layer, SQL layer, right? Storage engine layer, MySQL daemon. So what are these? So client layer are the application or user interacts with the MySQL via the client layer using SQL queries. So this is the topmost layer actually. So using this layer only, the clients can access MySQL, right? So whatever we will be using UI or command line CLI, that's the classical example of client layer here. So MySQL layer, I think this theoretical concepts are not required. If you are interested, can take a screenshot and go through this slide. And these are the components of MySQL: SQL query processor, storage manager, and obviously MySQL server and data dictionary. So I think that's enough of the theory part. Let's set up the MySQL, guys. So I told like there are two primary ways how you can access the SQL, right? So one is CLI way and the other is the normal user interface way. So MySQL, if you type MySQL CLI Windows, go to the first link here and click on the version which you need, or you can directly click on the download link here, and obviously see the versions, and the operating system must be Windows in my case. And you can go with zip archer or MSI installer. I will go with MSI installer since it's already installed in our case. So what I will be doing is that I will open this. So it will be asked should I run this, so click on next. So I think since I've already installed this, so it's showing a prompt like this. Just click on next, 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 guys. It will get automatically installed. So once it's installed, right, you can go with this particular search here, CLI, and obviously you can find command line interface search here. So it asks for password. Default, I think the password will be root, I guess. If it is not root, if you are stuck anywhere behind, there are various help sites like ChatGPT and Google. Obviously you can Google the error. So this is the MySQL. You should get a prompt like this. So once you get prompt like this, obviously the particular CLI is successfully installed in your system. So the other way to access the MySQL is using the MySQL workbench, guys. So MySQL workbench is the other way to access particular MySQL server. So click on here, and obviously you can click on downloads, and obviously you can take any versions here. So in my case, since I've already installed here, you can go with any version. Click on download now, which will be redirected to Oracle official website. And here, like, you need to select Windows, guys. So in Windows here, click on this particular link zip file and unzip it, right? It can get downloaded in your system. So since I've already downloaded it, I will not be downloading this. So this is an enterprise edition. I don't know which edition I have. Let me just quickly check it. So workbench, yeah, I think workbench C is the required one, I guess. Download workbench CE. Yeah, 8.0. You can click download here. So no thanks, just start my download. So once it gets downloaded, guys, just click on that and you can obviously download it. So let me open workbench from here. So once it's get downloaded, you can double click on run on this, right? You can click next, 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 right? I will not be selecting this because I have already installed this. So you need to get an interface like this, and obviously I think this will not be present, or else this will be empty by default, I guess. Click on plus symbol here, and you can give any name for the connection. Shall I say it's test connection? Let it be text connections, and you can obviously test a connection here. Obviously the password will be root by default. I think successfully made the SQL connection. I think now it's working fine. Yeah, that's all, guys. You should need to get like I think like that, and once you click on this, obviously you need to open a site like this. So whatever schemas or databases present will be present in the left section, and this section here is used to write a query like insert into table, anything, insert into, you can type any table name if it's present, right? You can do like that. And there is certain icons here, you can explore this, not in this video, guys. So yeah, I have made notes of this. So these are the basic commands. In today's video, obviously we will be seeing basic commands, guys. So these are the basic commands in MySQL. Obviously more we will be using the CLI because that's how developers operate MySQL. I'll be using CLI. The password is root, guys. The password is root. So I think the connection is secured, right? And it's connected also. So you can try out the first command here. Connect to MySQL is using this particular command. I think I have already like connected here, so I think it's not be useful. So in order to connect, like use the database, let me show what are the databases present here. You can use this particular command here, show db, show database. Click on enter. You can see the database present here. There's an e-commerce db, information db. Let me select this e-commerce db. I'll be using this particular use database here. So use database name is MySQL db, semicolon, enter. So now the database changed, right? So we can also create database using this particular command, create database. So let me give a command. So I think it's very confusing. Just let me clear here. System clr. If you enter, I think it's system clear cls, I guess. Yeah, system cls will clear the screen. So let me create a table. You can see for creating a table, the command is create database, database name. So before creating table, we need to create a database, right? In the database, inside database, there will be many tables. Okay. So create database test underscore database. Anything you can give, guys. So this is the name I prefer for my DB. So okay, you can see in the response I will be getting like query okay, meaning that the query has been successfully executed and I got a response like one row affected. Okay. This is the time duration, how much time it has taken to execute the particular query. In our case, it's create database name. So after creation of database, let me see if the database is present. Let me use this show databases command here, and let me see that. Obviously, you can see test database. So I think it's in alphabetical order here. You can see test database here. Previously it was not present. So let me just delete this database. For that, the command is drop database name. So drop database, I know. Let me delete this particular test database only. Test database semicolon. If I click enter, query okay, 0 rows affected and 0.06 second is taken. So let me once again see. You can use up and down arrows to move between the commands which I have used previously. If I enter this particular command here, you can see there is no test db here, right? Because we have already dropped that particular db. Let me clear the screen. So this show tables will list the tables for us. So let me see how many tables are present in particular table. I think it now needs to prompt an error that no db is selected. Okay, I think we have been in the e-commerce db. Since we are in e-commerce db now, it's showing the tables in the e-commerce db. Okay, there are this many tables, and we will be prompted to the error as I mentioned previously if the db is not selected, right? So if you guys encounter any error like that, you can use the command like use database here, use followed by database name, so that you will be not prompting to the error which I mentioned right now. So show tables, obviously these are the tables present. Let me just create a table, guys. Here let me just create a table here, paste anyway. This is the table which I expect. Okay, 0 rows affected. So once again, if I hit show, sorry, let me hit it again, show tables, right? I think you can see the table underscore name. Yeah, you can see the table underscore name here, right? So describing a table, so you can use this, even this also. Describe table name. In our case, the table name is obviously table name. So let me paste it once again. Describe table name will list all the table features here, like the field present in the table and the type of the particular field, and if it is null or not null, like that. There's like there is a particular keyword in this particular SQL, guys. So not null or null we can specify at the time of creation here. So if we see the particular create query here, in order to create a table in MySQL, we will be using this create command here, right? Create table is a particular keyword, reserved keyword, followed by table name. You will be using any table name you can give, and within this particular brackets, right, there's an open parenthesis and closed parenthesis and semicolon. So every statement should be terminated with a semicolon in MySQL. Okay, and these are the particular fields which we want. So first we need to give the particular column name and the type of the column, right. Here it's integer, similar to variables types or available in particular Java, like int, right. There's an int here also, and for character we will be using varchar. Okay, and 255 is the size or the limit of particular character which you will be storing, right. And we'll specify not null, meaning that this cannot be null. At a time of inserting value, this table will not upset a value if particular column 1 value is not been prompted or given at the time of insertion, right. Not null meaning that this value should be present at the time of insertion, or else it will throw an error that there is a not null constants here, like there is a not null attribute but you are not given a particular value for that, right. That error will be prompted to you. And this particular auto increment keyword is used to increment the value, like for first insertion this value will be 1, for the second insertion this value will be 2, automatically it will be incremented. And the primary key, this is a must guys, for every table there will be a primary key, and this particular primary key is used to differentiate between the tables, right. Like how it like to give an idea about this primary key basically differentiates the record guys, right. Records also in sometimes tables also, like when we referring to different tables, primary key reference key will be using. I will tell about the reference key later part. Coming to the primary key here, so this is a must guys. This primary, for every table there should be a primary key, and this primary key is used to differentiate the records in the table. Okay, so for example they can be two records, right, this like two values in the table having the same name, right. Then how to access, like if for example user want one particular, suppose say there are two customer to a particular e-commerce website with the same name known as Ram. Okay, there are two Rams. Now how to differentiate them? So in order to differentiate name we can assign IDs, right. So one Ram will be having ID 1, another Ram will be having ID 2. So we can specify or retrieve their values based on the ID rather than their names. So names can be similar. There are many people with similar names. But at the time of creation, once we assign a value to them, like ID to them at the creation, okay Ram, you take the value of 1. So at the time of retrieval, basically we can identify, I want this Ram value who has the ID of 1, right? So I will be taking those values. So that's the key here guys. Primary key is a must for every table. Okay. And inserting in data, let's see the insertion operation here. So in this table there are two not null attributes, right. So let me just do that. Let me insert this, and since there are two attribute values, the column 1 and column 2, like that's the particular attributes which are not null, right. So let me go by the value here. Since the column 2 is a not null, if I try to give no value, like let me give no value here, so what will happen guys, if I enter error, there is a column count doesn't match value count as row 1, because I am specifying column here, column 2, but I am not giving value. So just to decode this particular syntax here, this particular insert table is there, right. Just let me clear this. Insert into table, so this insert into is a keyword guys, result keyword. So this is a must for every table. If you want to insert a value, you should start with insert into the table name. So what table we need to insert a value, that particular table name you need to select here, and within brackets, these are optional usually. Within brackets you can specify the column name for which value you are giving, right. Inside parentheses you will specify the column names, and values is a keyword again, and what are the values you are giving inside the parentheses, you can give that. So since it's a varchar, it should be given inside a single quotation mark here. So character are always given a value or pass the value using the single quotation. Since the column 2 is an integer, we are passing as a normal argument here. Okay, so in our case let me just take this. Since it's a not null, let me enter here. You can see field to column doesn't have a default value because it's a not null, and it doesn't also have a default value, so it's throwing an error. If it was a not null and if it had a default value, it will not be an error, I guess, right. So let me try and insert this thing. Let me just copy. Let me first clear the screen, guys. Yeah, let me insert this. I think it was successful because these two are not null. So obviously we need to give value in order to insert any table, any value to this particular table, right? So if I go now and see the table, like show tables or anything you can use, let me go to describe table only. And once again, let me try to show you the context here. So here you can see the column 1 and column 2. The column 2 is a type of integer and it's a not null no, right? It's a varchar and not null no, and default value is null here. So at the time of passing, obviously you need to pass a value or it will throw an error as previously. Like the default value is null, like that. Okay, I think you are seeing the insertion now. So selection, guys, how to select table. Will show you how to select any value from a table. So let me first clear the screen, guys. So select star from table name, right? This select is a keyword, guys. This is used to select any columns. Star indicates I think I am like selecting entire, like in a particular table I am selecting entire columns. The entire column is represented by star here from table name, from which table you need to select. Okay, let me select everything from table name. You can see the value inside that. If you give this particular command, you will get retrieve the values inside that particular table. Select star from table name. Star means everything, or else I will give select only particular column 1. COLUMN, sorry guys, column 1 from table 1. So only column 1 will be getting, right? That's the catch here. Select star from table name or select column names from table name. That's all. And this is the same where condition also we can give. I think where condition is not required, I guess. Okay, let me explain where condition also. I think it will be a lot for single video, guys. So that's all for today, guys. I think, yeah, we will cover some basics concepts or comments also here. From basic concepts and comments have been covered here successfully. In tomorrow videos we will see, guys, we'll be covering queries in the MySQL sessions. If you have any doubt, guys, please comment down in the below. I will be happy to answer your queries in the comment section. And thanks for watching, guys. Stay connected. Bye bye.